So let's have a closer look at the dynamics in positive estuaries. So the first thing that we look at is the salinity structure. Again, there's a diagram here on the top right. Okay, you can see the salinity structure. So if you are measuring salinity from surface to the bottom, in your positive estuary, it's lowest at the surface and highest at the bottom. You get this salinity increase with depth. Okay, at any time, any location you measure, you see something like this. So, however, what the tides do is they actually move water into the estuary and remove water from the estuary. It's like an oscillation, and they shift this profile up and down in your estuary in one way and then in the other way, in one way and then in the other way. On average, the salinity structure stays the same. Okay, and this is through all the combination of features that you have in the estuary. You have advection, the movement, and you have mixing, which is the diffusion. Okay, so now let's have a focus on the flow structure. Okay, so if you average over a long time in your positive estuaries, you do measurements over several tidal cycles, and this is shown here in the top left, and the ocean is on the left in this diagram, and the river is on the right, and you look from the side. If you average over a long time, you get an outflow of water, lower salinity water in the surface layer towards the ocean, and you get an inflow in the lower layer from the ocean to the river. Okay, this is when you average over a long time. But however, if you know, just look at individual time instances, there are times where you have the incoming tides producing an inflow, okay, from the top to the bottom of the water, okay, an inflow everywhere, and at other times where you have an outflow everywhere. So it's only the average that can actually reveal the net or the residual flow structure. So you can't just go to one measurement and say, oh, there's always inflow into your system. Okay, so now let me introduce you to something that we call the tidal volume, V, and the freshwater volume, R. And this is shown here in the bottom sketch, in this one here. We want to define, or we want to estimate how strong the tidal currents are without doing measurements or much measurements. You need a little bit of information. How strong are the tidal currents? Because it's the tidal currents that can, through the turbulence, weaken stratification. And the way we do that is we look at the volume introduced and removed by the tides during a tidal cycle. So we look at the difference between water level at the high tide and the water level at low tide. And this is a vertical scale associated with that. It's called the tidal range. And if we multiply this with the horizontal area of your estuary, we get a volume. We call this tidal volume. At the same time, and we're talking about a tidal period, we have the inflow of a certain amount of river water into the estuary. And this volume over a tidal cycle, we call it R, the river volume. Okay? And these volumes this is what we compare to determine whether the river inflow is dominant in setting up the structure, the salinity structure in the estuary, or whether the tidal dynamics is dominant in setting up the structure. And you get some significantly differences based on this ratio.